Well, I will just start talking while I fiddle with this. So first, I just want to say thank you all. I think showing up here to improve your chops for transparent and open research is really important. I'm going to talk about how Dean, do you have your other? Let's try that real quick. And oh, okay. See, as soon as you start to doubt, it starts to work. And we're gonna mirror. All right. I work at a technology company. So I'm going to talk about how you can use the open source Gigantum client to do reproducible and collaborative things. So I'm Dave Clark. I develop tools and examples to facilitate collaboration, communication, and computational research. I've kind of tacked back and forth between trying to do research and then getting disillusioned that it's not possible, and then I work on some sort of meta-science for a while. That's what I'm doing now. This is Dean Claysas, who jumped up and helped out with magical technology work, Aura. He's our CTO and has also tons of experience with large-scale collaborations, especially in neuroscience. So coming back to the RT roadmap, like I look at this and I'm like, like I learn how to do something and then there's still like miles to go. So I think a really important component, and I thank Lorena for bringing it up, is automation of as much as we can. Computers are great at performing routine and tedious operations that have to happen again and again the same way each time. So that can give humans a chance to do what they're good at, like trying to communicate clearly. So coming back to a complicated thing, I realize that this is hard to read. I apologize, this is formatted by 538 for more like print, but it is one of the most interesting papers of 2018, according to Altmetrics, and it came out of the Center for Open Science. Basically, they gave a variety of research teams, about 30, the same data set, and asked, does skin tone impact the way that referees give penalty flags? And the fascinating thing you can see is that not one team, or no two teams got the same estimate and error bars, right? So every single time you turn the crank, you get at least a slightly different result. Of course, most teams got similar results, right? So you might reasonably conclude that there's probably some effect. But it's really messy, and ultimately it's really hard to coordinate an effort like this. So let me pop out of here real quick just to show you. Oh, there we go. So this is organized on the OSF, and it's really nicely done. Every little bit of information you might want to have is here. But I want to highlight one challenge is that when you're doing sort of post hoc reproducibility, you're doing stuff somewhere and then you're like copying it somewhere else where it's going to be published. Even though this is like basically the best people in the world who like wrote this platform, right? Something as trivial as like, oh, the README is in rich text, right? And like now it doesn't render. And so there's going to be a certain amount of like people who are intimidated by random control codes are not going to like, read through this. And then just getting into like a slightly more substantial problem, right, that doesn't have an easy fix. If you look at, wrong one. If you look at the way the submissions are organized, again, it's like really nice. They're all in one place. But if you really want to interrogate, sort of following on Fernando's idea, right, you're going to have to look through these documents and identify, the statistics and then maybe track down the materials and compute things. So it's just going to be cumbersome. And like I said, there's so many facets. If we can make things less cumbersome, I think it's worth doing. Percent. Right, so I just went through that. And those links, so, if you want those links, they're here. So basically, I'm going to show how you might organize a project like that if you use the Gigantum client. And to briefly explain what the Gigantum client is, it is something that takes a slightly specially formatted Git repository called a Gigantum project. It runs inside of Docker, and there's this client that you'll see in a minute that will grab the data from a project. It'll grab it from the cloud or import it from a URL, or you can make one. And it will build exactly the same environment and present exactly the same data and code so that you can pick up where somebody else left off. And it's also going to watch as you work. It's not going to make you switch contexts to the command line or a GitHub app. It's just going to, like, whenever you do something, there will be a Git commit, right? So you no longer really have to worry about making sure your work is stored so you can synchronize it. It's always ready to sync. There's also a really nice data set support. If you have like very large data, we can cherry pick stuff compressed to Amazon. I'm not going to get into that today. And so now I'm going to go to a live demo, which, you know, based on our experience so far, will probably break. So when you open the Gigantum client, it's pretty easy to install if you can get past installing Docker, which, you know, is just a installer for most platforms. You get this overview of your projects, and you can, let me make this a little bigger. Right, so you can create a new project or import a project from a URL. If you want to pick up and look at some of the stuff I'm doing today, that import is where you would go. And I'm going to pull up this example project that's about football and skin tone. So, oops, it's already running. So, as a coordinator, right, just like I would do with the OSF, right, and ultimately this could be linked into the as a component of an OSF project. You've got your README, right? People can read through that to like figure out, oh, these are the variables and so forth, and like understand how they're formatted and all that. Input data is organized in a separate tab. This will all get into the living file system once you launch into RStudio or Jupyter. Right, but then additionally, I'm providing an example of how to load the data in so that, you know, and I'll show you. So you can get into your environment a couple different ways. By default, we basically launch the correct environment. So if you click on an RMD file, it'll open RStudio. If you click on a IPyNB file, it'll open Jupyter. So you can look at, you know, what you might provide, and this isn't super complicated, but there's like this one little bit of, you know, mostly read CSV will, I don't know how many people can read that. So, you know, read CSV will get most of the columns correct, right? But then there's this one little bit that took me like, I don't know, 10 or 15 minutes of looking into documentation because the dates are formatted in date.month.year, which is like not standard, it's highly non-standard, right? But it's obvious, but you know, do I want 30 teams to spend 10 or 15 minutes figuring out how to like read a date? No, I do not. That's 5 hours of human work that could be spent on something useful, right? So, you know, there's this kind of philosophy I'm trying to propose of, you know, if you're going to pay this cost, pay it as far up front as you can so that you can actually take advantage of it throughout the research process. So once, as a coordinator, I've created that, everything's saved, I can just blow this away. I'm not worried about it. Let me get back to, right, so I would, as a coordinator, do that work. I would stop the container. Once the container's stopped, I can synchronize my changes. I'm not going to do that right this minute. Right, and then I'll sort of like switch hats, right? Now I'm on a research team, and I just downloaded this, right? So I've done nothing except type a URL into an import thing or grab it from my cloud tab. And, one of the nice things you can do is you can control the access that collaborators have. So you can have write permissions, so someone can't actually write to the master branch. You force them to create their own like private working space. So we're going to make a quick branch here. Uh-oh. Oh, that already existed. I will make a new branch so I can pretend I'm exploring this afresh. So this is exactly the same as where the coordinator might have left off. I can start RStudio. And I'm going to go grab some code real quick. Common practice for demos and sort of live coding. So I'm going to copy this. One simple strategy is naming files from the branch that they came from, right? So if I want to like go back and say like, well, what's the history of this? So I just made a copy of the thing I got from the coordinator, right? I can run that stuff again and then just add my analysis there at the bottom, right? And so I want to point out, I have not saved this. You can tell because there's, this is red. And this is pretty common, right? Like you don't necessarily save your code before you run it, but that can really mess up. Like if I printed this file to a PNG or JPEG or something, you wouldn't actually know for sure where it came from maybe. So we're actually, because we're supporting analysis environments that are through the web, we can intercept all the information in RStudio or Jupyter and actually save like, okay, you produce that graph, right? And you can also see like the code that was used to generate these graphs so that like no matter what happens, you have a record of what the analyst saw, right? And so that is sort of a simple example. Now I want to switch gears and just pretend like I'm in receipt now of a project like this. And you all can play with it a little bit more in detail. I tried to kind of be a bad researcher in rough logistic. So these results are not even rough, they're bad, actually. Right, and so what you can do, like, I'm in receipt of this, I have the full thing, I can like dig in and go and like explore the live environment, but I can also just sort of scroll back, and let me make this a little smaller so it's faster to scroll. So it's like, oh, okay, so that looks fine, like just playing around with the graphs, and then it's like, oh, there's another graph where like the difference doesn't look so big, right? And if I keep scrolling, it's like, oh, there's another graph where the difference isn't so big and goes the wrong way, right? So there's a sense in which if you have information organized in this way, right, and you're in a situation where perhaps you're training a junior colleague or you're coordinating a large research study and you're trying to keep everybody like actually being a good researcher, this is the kind of thing that can help people communicate like, no, really, this is what you did, and this is p-hacking, and like we need to talk about that because it's putting our research on shaky ground. So anyway, like I said, I get kind of overwhelmed by all the things that we have to do. So as you're going off and working with teams and stuff, I hope if you have struggles like teaching people good practices and Git and dynamic documents and all this stuff, we're trying to make some of this a little easier and more automated. I'm going to go ahead and make this public. And so if you want to come back and look specifically at this, there is some information in the slides about how you would do that. We do have a free demo server up that you can mess around with, but like I said, we're really designed to work on your own laptop or workstation. And if you want to get in touch, We're very interested in just supporting better quality of science, not just using our tools, but like really supporting that conversation. This is me via email or Twitter or most other social media. Please feel free to reach out. Thank you very much.